Hello everyone, this is a video tutorial on how to process drone images to produce high accurate map products. So we are using Pix4D Mapper to process the images into AutoMap and DSM and also to validate the accuracy of our map product. So first let's have a look at our study area. This is a small part of AIT. So as you can see, so this would be our study area, and you can see the layout of our ground control points and checkpoints. And if you look at the data set, we have drone images. So these images are taken from a Phantom 4 UAV, so Phantom 4 Pro actually. So we are going to use these photos and we are going to process these images into AutoMap and DSM, and we are going to use the ground control points also. So let's start the work. And first thing is you need to open Pix4D and you need to have a license of Pix4D, or you can use the trial version for 15 days as I remember. And first thing is, so this is the main interface. So you all are familiar with this interface. So I will quickly go through the steps. So go to new project. So before starting the processing, so try to keep a good folder structure so that after you make your products, it will not be confusing. So I'm going to create my project in the folder. I put all the images and other data. So this would be my main folder, and project name I'll give AIT process with GCP. This is a new project, and click. Okay, now we have to add all our drone images. So you can either go to the directory and select your images and add, or you can just select the directory itself. So it will add all the images inside that directory. So that which I will do right now is to go to this add directories option, and my images are in this folder, drone images with GCP. So I'm going to select this folder and choose. So you can see that all the images inside that folder are added right now, altogether 144 images. And after adding the images, click next. Now we have to verify the coordinate system and selected camera model. So camera model is automatically selected. So Pix4D has a rich camera database, so it knows that we took these images from the Phantom 4 Pro drone. So the camera parameters are already uh, predefined by Pix4D. So it's taking these parameters from its database. So we don't need to change the camera model, and you can see some of the metadata of the images. So one of the most important metadata is the image location where the drone takes these images. So you can see latitude, longitude, and altitude. Sorry. And if you look at this altitude information, you can see that it says around 146 for almost all the images, just slight changes. But I don't know the reason. Uh, the Phantom 4 records this height not in WGS84 coordinate system, and this is not the mean sea level height also. So there is a error in the height. So the error of the latitude and longitude, it is not that significant, maybe few meters, but this error is really high. So how I know that this altitude, it has an error. So if I draw the, oh sorry, if I draw the earth, so earth is some shape like this. So this is earth, and if I draw the ellipsoid, I'll choose another color. So we are using ellipsoid to model the earth, right? So I'm drawing slightly exaggerated figure. So this ellipsoid, it mostly fits the earth, but not exactly. So we cannot say that earth itself is an ellipsoid. So it's a kind of a model and the reference surface. So let me name this one. So this is our WGS 84 ellipsoid, and we are somewhere here. So you can see that some areas the ellipsoid is below the ground and some areas ellipsoid is above the ground. So right now, if you take the location of AIT, the ellipsoid is going above us. So if we are somewhere here, and ellipsoid, this mathematical reference surface, it's actually above us, and we are flying the drone at 100 meters. That 100 meters is, so this is 100 meters. So this is above ground level height, AGL height. And if we take the ellipsoidal height, if it is the correct ellipsoidal height, so this would be the ellipsoidal height, and this height should be less than 100 meters if this is correctly recorded. But right now it shows around 140 something, right? Yeah, 146. Sorry. So this recorded height has some error. So still I don't know what is the reason for this error. And the coordinate system detected by Pix4D is saying WGS 84 coordinate system, and for the height it's taking the mean sea level height. So it's thinking that this altitude is mean sea level. Even if it is mean sea level, it should not be 146 actually. So we have to change it. So the XY coordinate system is WGS84 ellipsoidal coordinate system, and if you click advanced options, then you can select the vertical coordinate system, and because of that error I'm going to choose arbitrary. Okay, and I have to click OK. And click next. So what we have changed is we have selected our vertical coordinate system. We have changed our vertical coordinate system into arbitrary system. Click next. And this is the, now we have to select the output coordinate system. So the automatically selected output coordinate system is WGS84 UTM zone 47N. So this is a projected coordinate system. So UTM zone 47 is the zone of Thailand, and if you want to change your height coordinate system, so your vertical coordinate system, right now the output would give the mean sea level heights. And if you want the ellipsoidal height, you can select geoid height above WGS 84 ellipsoid and keep this as 0. So this will give the ellipsoidal height. Okay. So you can either select the mean sea level height for our output and or the WGS 84 ellipsoidal height. So for the output, we can select this non-coordinate system because we are using ground control points. So by using ground control points, we are going to adjust the Pix4D is going to adjust the model, and it will give us the product georeference, and you can select vertical coordinate system because our ground control points are accurate. And then click next. And now we have to select the template. So our template will be 3D maps. What we will get is sorry, what we will get a ortho image and DSM. So make sure that the start processing option is unchecked, and you can click finish. Now we can see the image locations, and you can see the flight path also of the images. So these are the image locations where the drone took all the images. We can select our we can select our processing area. To select the processing area, go to map view, processing area, and draw. So it says how to draw the processing area. So left click to start drawing, move your mouse, which will draw a line to the next point of your area. Click the right mouse button to stop drawing. This will automatically close the area. So I'm going to draw our study area. So this the flight area is actually slightly larger because we are keeping a margin. So otherwise, if you don't keep a margin, there would be no sufficient overlap at the edges. So I'm going to mark our study area. Left click, zoom out, left click, right click. So this is our processing area. So our products, will get our product in this area. So right now we have to select our processing options. So go to processing options, and under processing options, so first step is initial processing. So key point image scale, I will keep it full, and you can disable generate orthomosaic preview in the quality report after the initial processing, so we can save a little bit of time. Point cloud and mesh generation, so you can keep the default settings for this one. And if we are generating digital terrain model, if we are asking Pix4D software to generate automatic digital terrain model, then we have to select this option. So point cloud classification, classify point cloud. This is only if you want automatically generated digital terrain model. Okay, so point cloud export is as this. And then 3D textured mesh, actually we don't need the textured mesh, we are interested in AutoMap, DSM, and right now we are creating automatically generated terrain model also, so we can turn this option off. If you want a 3D textured mesh, then you have to keep this option on. Okay. And DSM, orthomosaic and index. So we can keep the default settings. So the resolution is same as our ground sampling distance. So I think our ground sampling distance for 100 meters is around 3 centimeters. DSM filters, so you use noise filtering, and surface smoothing, keep it as sharp, because in this area there are sudden elevation changes. For example, when there is a building, so height change from one value to another value like very rapidly. So that's why we need to keep it sharp. Otherwise, if it is, for example, if it is an agriculture area, and then you can keep it medium or smooth, because there are no sudden elevations. So right now our option should be sharp. Raster DSM. So make sure this merge tiles option is enabled. And orthomosaic. Nothing to change in additional output or index calculator. So this would be our processing options. And then the configuring of the options is done. You can click OK. So still we haven't imported our ground control points. So the good thing about the Pix4D is it's helping us to import and mark the ground control points on the images. In order to do that, first we need to do the initial processing. So afterward, Pix4D can help us to mark the ground control points on the images. So what we have to do is we have to uncheck this second processing step and third processing step. So point cloud and mesh and DSM and auto mosaic and index. We can we have to disable these processing steps. Only keep initial processing. So this we are doing because we are going to import our ground control points. If you don't have ground control points, then you can do all these three steps together. So right now only initial processing, and click start. And this will take a while. So we can see that the key point generation. Right now the it's computing key points. So this is automatic process. So the color of these images change according to the which step uh, the Pix4D is processing. So I'm going to pause the video, and let's see after this processing is done. So this will take a little while. Okay, so now the initial processing is done. After the initial processing is finished, it will give the quality report for the initial processing. And under the summary, you can see the some information such as the uh, average ground sampling distance, time for the process, camera model, and so and so. So this is the quality report for initial processing, and we can close it for the time being. And this is our point cloud. So this is we called sparse cloud, and you can see the camera location and the orientation of the images in this model. So you can turn on and off the cameras if you want to explore this model, but these are just the key points, not the densified point cloud. So these key points are to used for image matching and to calculate the orientation and the position of the images. So that is the task of these key points. And now what we have to do is we have to mark our ground control points. So we need to prepare the coordinates of our ground control point in CSV format. So first what we have done is we have used RTK GPS unit to survey the ground control points. This is the layout of the ground control points and the checkpoints. We used RTK high precision RTK GNSS unit. So our ground control points would be this point 1, 2, 0, 3, and 4, altogether 5 GCPs. So AIT is relatively a flat area, so we can use 5 GCPs. So 4 in the corners, 1 in the middle would be sufficient. In order to check the accuracy, we are using another 4 checkpoints. So the difference between the ground control point and the checkpoint is that the checkpoints will not actively participate in the processing to adjust the model, but the ground control points will. So according to the ground control points, the model will be adjusted in Pix4D, but the checkpoints task is, as the name says, to check how accurate our map products are. Now what we have to do is we have to import our ground control coordinates. So before marking them in the measures, we have to import what are the coordinates. To import that, we need to create a CSV file. So that is how we can import the coordinates. And this is the CSV file I have created. And these ground control points are surveyed with high precision GNSS receiver. And you can see that the first column is the GCP name, and the second column latitude, longitude, and altitude. So this latitude, longitude, as well as the altitude is based on WGS84 ellipsoid. So this is geographic coordinate system coordinates, and this altitude is ellipsoidal height. So we have to keep that in mind also. So now we have to do is we have to import these coordinates. So I'm going to close this CSV file, and what you have to do is you have to go to project, GCP MTP manager. So here we can import our GCP coordinates, but before that, check this GCP coordinate system. So by default, what the Pix4D has selected is a projected coordinate system, WGS84 UTM zone 47N, and EGM96 geoid. This is the vertical datum. So vertical datum is selected as the mean sea level height. But this is not the coordinate system we have our ground control points, right? So you can see that in the GCP MTP table it says X, Y, and Z because it's UTM zone 47, and which is projected coordinate system. But our coordinates are in latitude, longitude, and the altitude is in ellipsoidal height. So first we have to change the coordinate system. So this says which coordinate system our ground control points is based on. So to change the coordinate system, click edit under GCP coordinate system. And we can select the coordinate system. You have to click the advanced option. You can select from list. Our datum is still WGS84 ellipsoid, but the coordinate system is geographic. Now it select what the Pix4D selected is projected. So if you scroll up, and you can see this globe, which means geographic system. So you can select WGS84 and click OK. And the vertical coordinate system, our GCP points are now in ellipsoidal height. The height datum is ellipsoidal height, so we have to select geoid height above WGS84 ellipsoid and keep this value as 0. So this will tell the this is telling the Pix4D software that we are using ellipsoidal height. But if your ground control points are in a different coordinate system, in a different datum, then you have to select according to your coordinate system. Okay, right now what we are using for our control points are is the WGS84 coordinate system. Now click OK, and then we can see that this table is changed. Before it was X, Y and Z, now it's latitude, longitude and altitude. Now we can import the coordinates of our GCPs. In order to do that, click this import GCPs button under GCPs MTV table, and coordinates order in our CSV file is latitude, longitude and altitude. If latitude, longitude is swapped in your CSV file, then you can select this one, longitude, latitude and altitude. In our case, latitude, longitude and altitude, and browse the file. So it's under GCP, inside GCP coordinates folder. You can see the CSV file. Click open, and afterward you can click OK. So now we can see the coordinates are imported. So we have to tell Pix4D that what are our ground control points and what are our checkpoints. And if you select the type of the GCPs we have imported, so all are now 3D GCPs. But we need to make this GCP 5, 7 and 8 as checkpoints. To do that, on the type column under GCP 5, double click and you can select, you can see the drop down. Click the drop down, select checkpoint. So GCP 5 now is a checkpoint. Same for the GCP 7, double click, drop down, checkpoint, double click, drop down, checkpoint. And now we have 5 ground control points and 3 checkpoints. Afterward, you can click OK. And you can see the location of our, after we import the coordinates, you can see the approximate location of our GCPs, and you can see the massive height difference is there, because this model is, the height of this model is not according to this coordinate system. So that's why we selected arbitrary when we are importing the images, and now we are going to correct it. How? By using ground control points. First we need to mark these ground control points in the images. So in order to mark, in this layers pane, you can click this expand this GCPs and MTPs, and here you can see all our GCPs and checkpoints. So first I am going to mark GCP 0. After you click GCP 0, this pane would appear, and here we can mark our GCPs. GCP 0 is on the road, so this is the approximated location, but the actual location, there's a huge error. You can see shift, and we have to correct it. So for the time being I'm going to minimize this one, and you can adjust the image size and default zoom level also, and by using the mouse, you can click left click and pan like this, and using your scroll wheel you can zoom in and zoom out. So zoom into a level that you can mark the center accurately like this, and then single left click. Okay, in order to pan you have to left click and hold. Likewise, in order to mark it, just a single click, and go to the second image. So you can find the GCP here. This is little bit tedious task, and Pix4D is helping us furthermore to mark the ground control points. After you mark it on 2 or more images, you can go to this selection, and select the automatic marking option. So now I'm going to click. You can see that marking automatically. There's a process to mark all the images automatically, and afterward these images, the GCPs are marked in the images. So after automatic marking is finished, still we have to adjust it. So you can see this circle represents the uncertainty of marking. So when we mark it manually with a good zoom level, then the uncertainty circle, it becomes small. And for example, here you can see that the automatic marking is not exactly in the center. So you can go and just click. You have to correct the correctly mark the center of the GCP. So you have to do to all the images. So this is just for GCP 0. Okay, so this is already marked manually like this. So zoom in using your scroll wheel, and you can point your mouse at the center and click, then it will this process is taking a little bit time. And okay, so there are some images we cannot see the actual mark, but Pix4D is showing this because it thinks that the marker is inside this image, that's why, but it is not there. So don't mark here. So let's say in if you accidentally mark in one of these images in a wrong position, so I'm going to click here, so it's accidentally marked right now. So what you can do is just hover over that image and press the delete key, and it will delete the mark. So don't mark it in these images, so because we can't see the GCP. So even if you can see the GCP and if you cannot identify the center of the marker, again don't mark in those images. Sometimes there will be blurring, so in that kind of situations, don't mark on that image, just hover over that image and press delete, and it will remove the marking. And this is done for GCP 0. So after you finish marking on all the available images, then go to selection pane again and click apply. Now you can see this GCP 0, it's showing 16. So we have marked the GCP 0 on 16 images. And next I have to go to GCP 1, GCP2, GCP3, GCP4, GCP5, 7 and 8. GCP6 is not here. You have to do the same step for the all these GCPs as well as the checkpoints. You have to mark the checkpoints also. So keep in mind. So I will do another GCP. So right now I will pick GCP5, which is a checkpoint, and click the GCP5 and images, which Pix4D thinks that GCP is there. GCP is visible, is shown here. So you can select the default image size as well as the zoom level. I'm going to keep somewhere here, and this is our GCP 5 center. Zoom in, zoom out using scroll wheel. So I click and hold the left mouse button to pan. Zoom in, mark the center. And after marking two images, you can go to selection menu and automatic marking. And then you have to manually check and adjust the images. For example, here, zoom in, go to the center and click. So likewise, we have to adjust all the correctly mark all these images. You have to find the center. And when you mark, you can see the this uncertainty circle, it becomes small. These images you can't see. And then after correctly marking all the images, click and apply. So do this process for all these GCPs, and to do it correctly you need to know like what are the GCPs you have put. Sometimes you are using natural GCPs, so keep a sketch of those GCPs and then you can mark. So for example, GCP3. So GCP3 is, it's a natural GCP. Go to Pix4D. And how you find what is the GCP? So always keep a sketch. So I know that this is the point. So this paint marking. So you can see, you can clearly mark. I know this point because I already did this processing twice. So I can easily identify the point, but in area that you don't know, so this might be difficult. Another reason is like this is inside AIT and I'm familiar with the area, so I can easily identify. But if you are doing a project in a remote area that we don't know, so we better to keep a sketch of these natural points if you are using natural GCP. So this is existing marker. Okay, so in order to mark it, the same process can be here. And then automatic marking. Sorry. This process you have to do for all the GCPs and checkpoints. Now I'm going to Now I have to correct the points. Already marked. So this process, manually marking this process, it will take time. But we can't avoid it. We have to check each and every image and mark. So Pix4D is doing a very good job actually. So we just have to adjust automatic marking. We can alright. The images we cannot see. And after marking, I will go and click apply. Okay. So we have to do for all other GCPs. So I'm going to pause the recording and I'm going to mark for all the other GCPs and checkpoints. And once I finish the marking, so I will demonstrate how to do the next steps. Okay. All right. So now I have finished marking all our GCPs and checkpoints. So you can see that the number of marked images for each and every GCP and checkpoint. So I have marked for all the GCPs and checkpoints. The next step, we need to re-optimize the model. So this initial point cloud as well as the initial image location and image orientation, so this has to be corrected. That is what we are going to do with uh, re-optimizing step. So you have to in the top menu you can click re-optimize and it will give a warning. So results of the first step, so some of the results would be erased for the initial processing step that has done before, and then you have to click OK. So this process will take a couple of minutes, I think. So this is an automatic process, so I will pause the video till this is done. Now the optimization is done, and when you explore the key point cloud, so sparse point cloud, you can see this sparse point cloud is now adjusted. This shows the initial location of initial position and the orientation of the images, and here it shows the optimized positions and the orientation. So the re-optimization is done, and the next process would be point cloud and mesh generation and DSM orthomosec index generation. We already made our processing, we already configured the processing options. So if I go again, so point cloud and mesh, so we can keep these parameters as default, but to save time I'm going to make the point density low, so it will process fast, but the point density of the point cloud would be less. And we are using point cloud classification also. If we go to DSM, because we are generating a DTM, we go to DSM orthomosec index. The settings we already discussed. And I think I forgot to mention forgot to do this change. So we need to create the raster DTM also. So this is automatically generated digital terrain model, and you have to enable this one under additional outputs. So this these two processes, point cloud and mesh generation, DSM and automosaic index generation, we have to do afterward. So initial processing is already done, so we can uncheck the process and we can turn on this process to process 2 and 3. Click OK. Now we can start the process. So after this step, all the products would be generated and the process would be automatic, and you have to click start. And this will take long time. So I'll come back to you after the products are generated. The processing is finished right now. So the quality report is generated and it's open. And if you scroll down, and here you can see the accuracy of the map. So accuracy is measured by the checkpoints. So in my case, you can see that we get very high accuracy. If you look at the error, so error is a measure of accuracy actually. So X error is less than 1 centimeter. Y error we get around 3 centimeter. Z error is around 3 centimeters. So we get very high accurate product. So we can close the quality report and we can check our products, which are AutoMosaic, DSM, and we also generated automatic DTM also. So you can go to Mosaic editor. The products are loading, you can see here. So this is the AutoMosaic for area. And you can explore the DSM, and this is the digital surface model. So the pixel represent the height. Go to the DTM. So this is automatically generated DTM. So you can see some errors are also there. So in order to eliminate these errors, you can use manual method to derive DTM out of DSM. So these automatically generated DTM, it has some issues actually. So this is it. This is how you process your drone images using ground control points to generate accurate AutoMosaic and DSM. So your results would be in. So you can go to your project folder, and under DSM and Auto, you can find your DSM. Under Mosaic, you can find your AutoMosaic, and inside extras folder, you can find automatically generated digital terrain model. So you can use ArcGIS or QGIS, any GIS software or remote sensing software to open and explore these products. And if you go to initial processing report, and here you can find the quality report, the same quality report we have seen in the end of the process. Okay, so this is the end of the video. Thank you. So this video was a little bit long video, and all the data set I will include in the I will include a link to the data set in the video description. So you can process the same data set, or you can try with your own data set. So the processing steps are same. Okay, thank you so much.